Hello, I'm James Snell. I'm from IBM. IBM's technical lead for Node. I'm also on the Node core team. There was a slight mix-up, I think, in the agenda. It talks about, we're going to talk about some of the standards work and stuff we were doing. I thought I was going to be talking about HTTP2, very closely related. We can talk about everything. But I'm going to kind of go through some of the efforts that I've been doing implementing HTTP2 in Node Core. So this is not using any kind of libraries. This is building it into Node. This is a kind of a what's coming in the future talk. A decision has not been made yet whether HTTP2 really is going to go into Core yet. It's very, very early conversation. It's something that's most likely going to happen. We just have to kind of figure out how and when. So this is very future looking. A very important thing, saying HTTP2 repeatedly is darn near impossible. So the TTP is silent. I'm just going to call it H2, okay? And HTTP1 will be H1. All right, so no HTTP2 over and over and over again. So let's talk about H2 in a nutshell. H1, basically simple message passing, right? You're taking a bit of text, some binary, passing it back and forth over a single connection. Everything is basically done in sequence. You send the request, you have to wait for the response to come back. You can pipeline these things by sending multiple requests over a single connection, but you have to wait for the responses to come back in order, right? So if if you send a GET request and you're getting a 10 meg file back, and then immediately after that you're sending a post and just want something simple back, that post response is going to wait until that download is received. The other concern is if you are doing GET and posts, one is an idempotent, the other is non-idempotent, you can end up with all kinds of different issues if you're pipelining those types of requests over a single connection. It ends up leading to a significant performance bottleneck, right? HTTP2 was specifically designed to deal with that bottleneck, and I'll explain that in just a minute. So, okay, I'll explain it now. I constantly forget what order my slides are in, so I'll skip ahead, come back to it, and then realize, I need to actually, so there's a little head of line blocking issue going on up here too. H2 switches to binary framing. What it does, and this is the primary difference with H2 compared to H1, is that it switches it up to, rather than sending a bunch of text messages that are line delimited, they are binary packets where your data is split up into individual frames. What this basically allows you to do is multiplex multiple requests and responses over a single connection where the data can be broken up into discrete packets and sent. The packets cannot be sent out of order. There's no sequencing of the frames. But you can send multiple requests and multiple responses at the same time, right? And that is the #1 difference with H2. There are a number of other things here that are included. Stateful header compression. So what does this mean? When you send a bunch of headers in your request, right? Typically in H1, if you look at it, most of those headers don't change. You're sending the same block of data every time you send this request. Cookies are a good example of this, right? Because those things don't change, and because of how they're encoded, for instance, dates take up 29 bytes per request, right? If you're sending a date back and forth. Because of how these things are encoded, that's a huge amount of data that's just lost. It's just taken up just by sending information that rarely changes or could be encoded in more efficient ways. So what HPAC, the header compression mechanism in H2 does, is it uses the delta encoding that sends just the differences between one request to the next. So if I open a connection, send an initial request, it's going to have a set of headers, right? The next request I send will only have what headers have changed. And it'll assume that the other headers that were sent are just still in effect, right? Now you have to tell it, give it some indexes and stuff. So it uses a couple of bytes per header. but it's not this huge bucket of information that it doesn't change from one request to the next. Significant savings in bytes sent over the wire. It does, however, add the fact that we're taking H1 from a stateless protocol to H2 being a stateful protocol, right? The state table for these headers are maintained. There's 2 for every connection, 1 outgoing, 1 incoming, right? The outgoing, you get to choose how you use it. The incoming one, you have to do whatever the sender is telling you to store, okay? Because they're the ones they're the ones making the decision of what to store. You can tell them how much you're willing to store, but they will be the ones that tell you what you actually have to store, right? Based on those constraints. So there is a significant amount of new state management that's happening that H1 currently doesn't have to deal with, and it adds a new constraint on implementation. So I'll get to that in just a bit. The other thing is server push. A better name for this would be assumed requests. What a server push is the server, like right now you request a web page. Typically the web page is not just that one page, right? There's a lot of JavaScript, there's images, there's a lot of other resources that come along with that thing, right? So what server push is the server knows what additional resources the browser, the client's going to ask for. So it'll just go ahead and automatically start pushing those to the client, right? And it does this by assuming a request and then sending an initial heads up saying, hey, I'm assuming that you're going to send this, and we'll give you a bunch of request headers. And it'll give you the opportunity to say, yes, go ahead and send it, or don't. Right? And then it'll start pushing that response just like it actually received a request. And it is handled as a distinct stream just like anything else, but it's tied to the original request. So the other thing is prioritization and flow control. And the number one question I've always got on this was, doesn't TCP already have prioritization and flow control? Yes, it does. This is a second layer because we are adding multiplexing. They discovered early on, the designers of the protocol discovered early on that H2 would have to have its own separate prioritization and flow control in order for it to actually work with the way that they're multiplexing everything. So adds an additional layer of complexity that H1 currently doesn't have to deal with. Right now you just send a message and get the message back, right? Here there's a lot more going on. And then protocol extensibility, won't go into too much of that. We're using a binary framing protocol. You can add new frame types. Right, every frame has a stream ID and a type, right? So you can add new types of frames for the stream. The end result of that is that you can actually design new protocols using this binary framing model, that you're not actually just limited to the HTTP semantics, right? There's other things that you can do here. There's been a variety of things that are being looked at for adding checksumming to the protocol. Adding these frames and adding some additional security layers and that kind of thing. So there's a number of things that are interesting there. Bottom line of all this is H2 is not an evolution of H1. It's a completely new protocol. It'll still use port 80. It'll still use 443, right? But it is a brand new protocol. And that's something that causes quite a bit of confusion. The confusion is not helped by the fact that you can serve H1 and H2 over a single connection, right? You can have, a server stood up that will allow the client to decide how they're going to communicate, right? And if they want to talk H1, then your server can just talk H1 with it, But over the same port, if a client comes in and says, hey, I talk H2, that's what I want, the server can also communicate with the client over H2, all happening over port 80, right? Which makes for some very interesting things, by interesting I mean very problematic things for intermediaries, right? Because they have to be able to support this as well and being able to do multiple things. So there's a lot of confusion here, and what you'll end up with is servers that support only H2 over one port, other ones that support only H1 over port 80, and there's some negotiation going on. You want to look at the alternate service spec to kind of figure out what some of that, how some of that stuff works. I'm not going to go into too much of that right now. So now, what about core? So that's the overview of the protocol. How do we go about actually getting this into Node core? To really understand that, let's take a look at how H1 is currently implemented, right? But, you know, the first thing we have to do is kind of figure out, okay, why? Why are we going to do this? Personally, I think the reasons are pretty obvious. I have my issues with the way H2 is designed, but I recognize, you know, that's kind of where things are going. Probably be a good idea to get it into core, right? So let's look at H1. The way it works currently, we have libuv, and we have the net module, TLS module, HP module, right? These are the things that people are typically using. Inside core, inside the native bits of core, we have this node HPCC and the HTTP parser library. So the libuv, net module, TLS module, these are the parts that actually manage the connection, right? They don't know anything about HTTP. All they do is establish the connection and get that going. When we want to create an HTTP request, we rely on the HTTP module to do that. As data comes in over the connection, the libuv hands it off to the module, which does all the actual semantics. But we have this little thing in here with the HTTP parser, right? What HTTP parser does is takes that input data, parses it out. It's very, very specific to the H1 message format. So it's a text parser. And it's a very complex text parser. If you ever, you know, I recommend everyone to go take a look at it. You know, if you look at it and can't figure out what's going on, don't worry about it. I've been in that code many, many times, and I still can barely follow what's going on. It's a very complex bit of code. But what it basically is just a text parser, right? So the HTTP module gets that code, or gets the data from the connection, passes it off to the HTTP parser, which has some callbacks to come back and say, okay, we received some headers, we received some data, go do something with it, right? That gets passed back to the HTTP module, which you know, carries out the user code for actually handling the requests, and then passes that back up the connection and sends it back out. That's basically how the HTTP module works in Node. Like I said, the HTTP parser is written very, very specific to H1. It's extremely difficult to modify. H2 is a very different protocol. So we can't just take the existing code and easily make it also talk H2, right? What it requires is basically a new stack of code inside core that would sit in parallel with the H1 implementation. There's a couple of good things with this. One, it means we're not touching the H1 implementation, so we're not breaking backwards compatibility with anybody. So that should be awesome. All the existing HP apps should continue just to work, right? And we can layer in H2 support as an additional capability by treating it as a separate protocol. So let's see how we would make that happen. Similar story. The picture is almost identical to H1. We still have the libuv net module. We have this new HTTP2 module. And we're using a library called ng-http2. I'm very happy this thing exists because it means that there's significantly less work we have to do to get this working in core. ng is perhaps the best library implementation of H2 available right now, and the API is fantastic. Definitely well worth going to take a look at. It's a C API, very logical. It's very straightforward to use. But in order to get it working in Node, we need a little bit of glue code. So there's going to be a new class, a new C class in there that kind of connects it into Node's API and how Node exposes data and works with libuv. But the flow is basically going to be the same. We have, I just explained all that. So we still have libuv handling the connections for us, the net module, TLS module. The other thing that's important to understand about H2 is that for all practical purposes, TLS is required. The spec doesn't require it, but all of the main client implementations, Chrome and Firefox, they refused to implement H2 without having TLS, using TLS to establish a connection. So while in Node we will support the ability to stand this up, without TLS, we'll be able to create a server that doesn't require TLS. For most practical purposes, your clients are going to be expecting it and requiring it. So we're still going to be using that. The data comes in. We pass it off to the HTTP2 module, which hands it over to ng-http. That library handles all of the state management for the header compression. It handles all of the parsing of the binary frames. All of the state management is all encapsulated within that library. So it makes it very easy for us. It doesn't do any of its own I/O. So we still use libuv to actually, manage the I/O. We use the net module and the TLS module to handle those bits. And we just create a little bit more code to interface with NG and to pass data back and forth. And NG uses a callback model, which fits very nicely within core to actually get that data back and interface with the user layer, user code. Again, the API is pretty straightforward. I mean, we can take a look at some of the code. As it has, right before I left California, the demo was working fine. I get here this morning and it's seg faulting. So I think I updated something. So I can't actually show the demo I was going to show unless you guys want to see some seg faults, which are always fun. But I'll show you some of the code. It's very rough right now, very early. The goal is to try to get something done experimental by the Node V8 timeframe, which is April 2017. So between now and then, there should be a significant amount of development going into shoring this up. HTTP has two layers of semantics. I kind of talked about this a little bit. There's the framing layer and then there's the HTTP layer. The framing layer deals with streams and the frames. Any single connection can have any number of streams. All of them can be active at the same time. Every stream is made up of a bidirectional flow of these individual frames, right? That is a distinct layer from the HTTP semantics. You can use that based on how they've defined it in the spec to send HTTP requests and responses, right? But it's actually not required. You can implement the framing layer independently, and there's some very interesting things you can do with that that have nothing to do with HTTP semantics, okay? The plan is to introduce two APIs for this. One is that deals with the framing layer, right? Allowing developers to work specifically with the streams and the frames. And if they never want to actually do any of the HTTP stuff, they don't have to. They can. You can use it in a number of interesting ways to expand your HTTP applications. But if there's other things you want to do with it, you'll be able to. So that's something that's, that's unique. And the other thing that will allow you to do is if you don't think that Node's HTTP implementation is good, you can write your own on top of the lower level API, right? So hopefully enable the module ecosystem to do some more interesting things. This is the higher level API. The goal here is to make, if you don't want to deal with the streams, you don't want to deal with the frames directly, have an API that is as close as possible to the existing HTTP API, with the goal of trying to have as much existing code continue to work as possible, and all you have to do is change which protocol version you're using under the covers. It won't be 100% fidelity. There are some things that are missing from HTTP2 that were in H1. For example, H2 does not have a status message. Like on the response, you can specify a status code and a status message. Message was dropped from H2. It doesn't exist. All you can do is do a status code. So that API in H1 that allows you to set the status message, well, that's either going to be a non-op and does absolutely nothing, or it's just not going to exist in the H2 implementation. There's going to be small differences like that that could end up creating some little gotchas and bugs as you're trying to migrate. So we're still documenting exactly what those changes are going to be, trying to get an idea of how those models are going to vary. But there are going to be some variances. Some of the other variances are going to be caused by the addition of new features like push streams, right? The current API has no concept of a push stream. How do you initiate it? How do you manage it? So we're going to have to introduce new APIs for dealing with those things, right? As we're going through this, we're still very early in the conversation, so if you have strong opinions on how that API should or should not work, there's going to be URLs here at the end where some of the conversations are happening. I would love for more people to get involved in the conversation. So please, bring new ideas, and even if the idea is like, why are you doing this? Just make it a module. Bring that. We need to hear that too. If there are very good reasons for us not to have this in core, then we need to have that conversation, right? And like I said, the final decision has not been made yet. Okay. So what about the lower level API. So, you know, if you're familiar with how streams work in the event emitter model, then this will be, you know, pretty straightforward, right? We're going to create a session, use events to basically say, okay, when do I receive a frame, you know, and then being able to respond and deal with that. It's going to be a very familiar API, but will allow you to deal with the lower level semantics. You will be able to mix the two, so it's not either or. You will be able, you know, if you want to use the higher level, want to do some more interesting things at a lower level, then you'll be able to do that as well. There's a couple of things that we are not doing, at least initially, just because of the additional complexity that it requires. Initially, things like prioritization and flow control may not be directly exposed. We may get those APIs eventually, but we want to make sure the basic protocol implementation and the basic APIs are right before going into too much of this. Like I said, the protocol model is extensible. You can add new frame types. You probably won't have an API initially for adding those types from the user's point of view until we figure out everything else, right? It's a matter of just prioritizing the amount of work that's going to be involved. Okay, and then protocol negotiation is kind of a sticky issue. We got to figure out how all that's going to work because, you know, there are variances in how all the various implementations are doing this right now. I'm kind of figuring out what all those best practices are. We'll get there, but, you know, it's a longer conversation. Some of the next steps. The first one's a big one. We have to actually convince everyone that this is something we should do. If you have strong opinions, please let us know. Saying, okay, just make it a native module out on NPM is a perfectly valid argument, right? And if there are more people arguing for that, and if those are, you know, if there's nothing we can say about that argument, then that's the way it needs to go, right? There's nothing says that we have to have this in core. We're working through all the details. Most of the details are API. The implementation, I was able to get a basic implementation using NG up within about 4 days. I'm not saying it was a good implementation, it was just working. All of the details are on how do we actually expose the API, right? And how do we do that in a way that's not going to break everybody? How do we do that in a way that's consistent with how the existing HTTP implementation works, that kind of thing. So lots of details there. And of course, testing, docs, examples, all of this is going to take a significant amount of time. That's why we're looking at, you know, Node V8 April timeframe before having something at the very least that's experimental, right? To get involved, the Node EPS, if you're not familiar, it's Node Enhancement Proposals. The S is a plural, it's not part of the acronym. And what these are basically proposals for improving Node, significant portions of the Node API and internal implementation. This is where we have all the sticky conversations about how do we actually make these improvements without breaking everybody. And there's a number of conversations that are happening there. You know, things related to the ES6 modules are going on in the EPS repository. The stuff with H2 is happening there. There's a variety of different conversations that are happening. So if you're very interested in the direction Node is going, the EPS repository is definitely something to keep an eye on and to jump in and get involved with. Okay, some very interesting conversations happening there. And then I created a repo. There's very little there. I'm actually going to start putting the initial code in next week. That'll have the start of the HTTP2 implementation in core, right? And basically, this repo is going to be it's a fork of core with the HTTP2 stuff in, so you'll be able to build it and actually try it out and see how it goes. It's going to be a very iterative process as we go. That's it, basically. I wanted to open it up for questions, and I know, you know, on the agenda we were talking. It was talking about, you know, a lot of the other standards work that we're doing. So if there's interest there, I can talk through some of the additional things we're doing. So, any questions? I'm sorry? Yes, so the question is, would we keep the H1 and H2 implementations in parallel? Yes, absolutely. Nothing would be, you know, the H1 implementation isn't going anywhere. right? It would still be there. Eventually, we would have the option with the protocol negotiation to be able to actually, stand up a server which can speak either one, right? How exactly that's going to work yet, I don't know yet. So, okay. Any other questions? Yes. Ballpark, at least an experimental version of it by April. By April 2017 is where I'm targeting like an experimental version of it to be ready to go. Node 8, yeah. Node 7 is going to be out in October, and Node 8 out in April. So whether it will be bundled in Node 8 or whether it's going to be experimental in this other repo, I don't know yet. That conversation has been, we haven't made that decision yet, but that should be when to look for something that's actually usable. So, okay. Any other questions? Any questions about the protocol? We can go through some more of the details of the actual protocol itself too. So, okay. All right. Well, thank you very much.